The last session was really about what we're doing today, and you guys are already asking a lot of questions about what next, and that's what we're going to concentrate on here. So Eva's going to introduce a series of broad topics, and then each of the other four presenters will talk about specific topics within this, which has to do with the future, sort of where we're heading. So Eva, why don't you take it?
Thanks. So really, the questions that I think the future starts presenting is, why do we study the future and why do we really care and how important is it to us and how do we find out more? And so as an interest of my own, I have been interested in the World Future Society for some time and have been involved in sort of trying to look at the future from a designer's perspective to think about how that could impact me or how that could impact our team and what we're doing. And so I think that really, when we talk about what is the study of the future, it is really looking at what the possibilities might be and the probabilities that could affect us or could impact our client. And so it's pretty obvious why it's important to us, because that's what we do every day. We build things that last and we design things that last. So it's not frivolous thinking to try to understand what it is that might happen and to be ready for it. And then how do I learn about the future? I think there are many opportunities now. I happen to be friends with some of the folks over at the University of Houston who really, I think that's one of the places that the future studies actually started years ago. So World Future Society is a place to look, and then The Futurist is one of the magazines that I always read and get a lot of information from. But to go on and to sort of push us a little bit farther into this, Jonas Salk is a Cincinnatian who was the creator of the world's first polio vaccine, and he said that our greatest responsibility is to be a good ancestor. This is particularly a relevant idea in our design profession, and the reason that we should take the future seriously. In our work, in politics, in our choices, in the possibilities we embrace, and those we don't, our actions have consequences. The issue of being a good ancestor is challenging. It's become particularly challenging when we realize that even small choices that we make each day matter. It's not just the multi-billion-dollar projects or the world-altering ideas that will change the lives of our descendants. Sometimes, most of the time, profound consequences can arise from the most prosaic of topics and actions. Video games, camera phones, Google Earth, and the myriad of day-to-day technologies that individually may attract momentarily notice may also, in combination, offer us a new way of grappling with the future world and the different views that are radical from our own. And many of the thoughts that I have today are from the futurists, which I mentioned, and also James Cascio, who is an author who writes about the future. The 10 trends that I want to really sort of talk about are trends that I think are in our everyday life right now that have a great, pardon me, that have a great impact on our future and that we can do something about. So the first trend, really, I'm going to go through these 10 trends and I will go through them one at a time and talk to them. And then our team is going to sort of pick up on some very deep thinking about culture and emerging technologies and sustainability. The first trend really is water and food. And obviously, water is the most valued asset with global interest, demanding our attention for building cities, for infrastructures, and for landscapes that retain and direct the growing of water in our cities. A report from the United Nations states that 2 out of every 3 people in the world will be facing a water shortage by 2025, a situation that will inevitably lead to a global conflict. In the very near future, clean water will be the world's most valuable resource, the new oil. And just as a side, by ArchiWorks, which is a school that I have been involved in for a number of years, is studying water this year and its impact on cities and looking at a model. This is where research really comes in, and looking at a model that can be used in cities around the world. The second topic that relates to this, of course, is food. So the sustainable approach to food scarcity in the developing countries, better move this on, can be eliminated by assisting micro-enterprises in growing food. Just as an example on this, I heard from one of our projects this week that we had engaged the food service people at the university and the landscape architect to look to how they could actually grow food on campus and compost the food and use it as part of the food service in the facility. So I think that we can make a big difference by bringing people together with ideas that just come about. The second topic is time and speed. The speed of response has accelerated 10 times in the last decade. How can we respond to deliver complex projects in a nanosecond? Third, work, restore, reset. An individual's professional knowledge is becoming so obsolete that we need to make changes in terms of our education. Most professionals will require continuous instruction and retraining. At any given moment, a substantial portion of the labor force will be in job retaining programs. And so that sort of sends me to think about, well, maybe in the future, instead of thinking of just universities, there may be another level of education that could be about training and possibly could be done through gaming. Number 4, globalization. Urbanization will hit 60% by 2030. As more of the world's population lives in cities, rapid development to accommodate them will make existing environmental and socio-economic problems worse. Workforces on the move will exacerbate social conflicts. Empowering girls through education will improve future communities. Number 5, the information society. Hotel rooms will become interactive, anticipating your need like a built-in butler. Major hotel chains are testing alarm clocks that run away from you after they go off. Digital peepholes that display visitors on wall-mounted LCD screens. Lights that turn off when you leave the room, and more. And actually, so many of these things are happening probably in our home right now, but those concepts are now moving to hospitality. Energy. MIT is harnessing energy from movements of crowds to provide lighting and safety to backup systems. A crew of 30,000 moving to and fro could create enough power to run a small electrical system, or perhaps bring a building's elevator to safety. A great idea for design innovation and value. And currently we're working on a project in Oregon that captures the energy from students, and we're going to try to power some of the activities that go on in the arena. So actually, if you think about that, and you think about all the train stations and all the airports and all the healthcare institutions and things like that that have people everywhere, it's a great idea to develop sustainability. Number 7, love and warfare. Military people will use neuroscience breakthroughs and advanced understanding of the mind to win future wars. Culture. The emerging importance of culture and design. We are engaging new processes and awareness of culture in designing buildings for a diverse cultural audience, for a specific cultural institution, and/or in regions with predominant cultural ideologies and traditions. And Allison's going to talk about this more later. Number 9, emerging technologies. Current and future technologies support a rigorous change in the way we deliver work processes, and collaboration. And David is going to share his work on design modeling, integrated design processes, and technology innovation. Whoops, sorry, go back. And also, as part of emerging technologies, we have advanced diagnostics. And Anthony Feldman is going to talk about that and share his work in the area of advanced technologies, diagnostics. And then finally, Phil is going to talk about sustainability and Perkins & Will's 2030 initiative. So I'm going to turn it over now to Allison.
Nobody said howdy yet, so I'll say howdy. Howdy. My name is Allison Williams. I'm the design director. I'm a design director and design principal with Perkins & Will. Every 2 years, Perkins & Will's leadership gets together, convenes somewhere, usually in the United States, to look over our shoulders at what we've done well, what we could do better, what we see coming up in the future. In 2007, the leadership group convened in New Orleans, thinking that we should go somewhere where our dollars would count and where our brains could help and where we could actually re-up on the message on the back of our little green card that talks about ideas and buildings that honor the greater goals of society. We use that format to really solidify and formalize a commitment to working for the public good, for welfare of the whole, and to use our specific skills as architects to provide services to those unable to afford them. The reality, oops, I need to change this. This would be much more interesting. This would be much more interesting if the next slide were up. So I'll just go to the next slide, because we all recognize that as being New Orleans before and after the hurricane. Our ability to demonstrate how pro bono can succeed while ensuring high-quality design of the same caliber as traditional work. This allows us to engage our local communities, enhance our creativity, and to educate a broader public, profoundly and emotionally rewarding in its effect on us as professionals. So we spent 2 extra days, a day and a half, beyond what we would normally spend, to do a number of things that we pre-planned. We did a new plan for Dillard University. We did some renovation at City Park. We worked with Priestley School, which is a school specifically for kids, high school kids, middle school kids interested in architecture. And we built houses with Habitat for Humanity for a day. And then we convened some experts on the subject of what it was going to take to rebuild New Orleans, including geologists and forward thinkers in education, to help us understand what message we could take back to our individual offices. And so as we left, there were little pieces of that experience that went out to all of our offices. I know that we have here our Houston, a little piece of the Houston office representing our social responsibility efforts. But I think the main thing is that this firm has always treated social responsibility in a very integral way. This formalized it, and so it is really a state of mind. We don't want to call it anything more than that, but just a way to celebrate and monitor ourselves to make sure that we stay on track with it. Let me go back. So I'm supposed to be talking about culture. I don't see it as a trend, actually, but more just it's emerging as a function of work in our cities, as part of a global practice with a broader audience, a diverse population, a diverse workforce, minority populations living within a predominant culture. I mean, we don't want to pretend, as we talk about how we integrate cultural thinking into our work, that we're sociologists or anthropologists or scientists, but rather that we gather these resources around us, that we know we need to gather them around us. And we need to educate ourselves in order to know what matters. Really, for me, that's what it's about. Understanding what matters for a certain client in a certain place with a certain program. Our task then is to define it and abstract it as architecture so that it resonates with the relevance about the place, the context, and the culture of the place. So the hope here is that I'm just going to whet your appetite about this topic by really screaming through 4 different ways of thinking about culture. Ethnically specific culture, where you're designing for an ethnically specific user or content. Border culture, which is at that moment at that third place, which all of us on border states understand, that third place where cultures and economics become indelibly connected, yet disconnected by politics and a magic line in the sand. The culture of women in Islam, which opens the subject of privacy for women and the social and religious orders that become primary organizing factors, and island culture, which Eva touched on, the politics of water, and the quest for political independence, and how that can shape an environment. So we'll start with the August Wilson Center, which was won by competition about 5 years ago. I'm going to try and just touch on some of the things that were fundamentally important about the beginnings of these projects and the premise upon which we tether our understanding of what matters as we move through the design process. I should say all this happens in addition to all the programmatically important charrettes and user groups and everything. This is not instead of or as different from, it's in addition to. The August Wilson Center, which was one of those perfect storms in Pittsburgh, Pennsylvania, the coming together of a group of people who really wanted to celebrate African American culture in Pittsburgh as a major contributor to the Steel Belt with the Italians and the Portuguese and everyone who convened there as immigrants to create that place. And because that institution saw itself as wanting to be part of the place, they chose as a place to make an iconic statement for the institution in downtown, right across from Vignoli's brand new convention center, as opposed to the traditional location in the black community of the Hill District. And one might say, how blasphemous to do that, but in fact, it said everything about the institution's feeling about its own future, its sustainability, not only environmentally, but institutionally. And it also said something about the fact that the institution was not static. It doesn't see itself as a museum, it sees itself as a place of education, and it's not just for African Americans. So you can see the site, which is right downtown. It's got 328 feet of frontage on Liberty Avenue, which happens to be the north-facing side of the site. So the idea there became to bring forward a few items of iconic importance to the African American community. First of all, the dhow, which are the sailing ships that carried the culture from the continent and beyond in the diaspora and through the movement of goods. The connection to the land, which is this incredible city wall in Zimbabwe. These are things that we learned, although won by competition, we touched on these as being important features that needed to be abstracted in the design. And then the transformation of the commonplace, the notion that if you took something very common and you anointed it with meaning, and that meaning is something that everyone needs to be able to grab onto it somehow. So take the mason jar. As you come along this place, first of all, everyone associates with the place in a different way based on what's inside of it. And so whether it's jelly or marbles or if it's empty, at any time of the day, it would be a touchstone for people. And this is from our competition, actually. I believe that this image is one of the things that resonated because, in fact, very energetically, it tried to talk about the contents of the building rather than the building itself, and this frontage along Liberty Avenue. Another thing about sustainability, the building is actually designed in order to hold a 10-story building on top of it for the future growth of the institution as future exhibition space or condominium space. So that was one of the components that really was about cultural sustainability. So many of these institutions end up dead because they use their money for construction and they have no resource for sustainable financial support. This is the building as it finally is under construction and to be open in May. Little smaller. One of these things about working with cultural institutions is endurance. And so 5 years later, after the competition, we end up with a 2-story instead of a 3-story building. The dominance of the theater, a 500-seat theater with a full fly, about 20,000 square feet of exhibition space. And the other thing that was really very important in the African American culture is also the importance of the street. So lining the building up along the frontage and creating really an extension of the sidewalk, a place where people can, without paying, can just walk in and become part of this place where impromptu things can happen, children can sit, spoken word can occur, and there's a retail component and a cafe that's associated with it, and a theater, which was fought for tooth and nail for spoken word, dance, theater, and the like. And this is the building under construction a few months ago. So I think it's going to be a very successful institution based on really the understanding of what was really important to that institution. This is just a plan showing the simplicity of on this triangle, I forgot to mention, site is a triangular site, a very, very difficult site, and figuring out how to fit it all in. Okay, and the next sort of quick discussion is about Calexico, this border crossing at the intersection of Calexico, California and Mexicali, Mexico. Calexico's population is about 40,000, and you can actually see the line here, the difference between Calexico and Mexicali, whose population is about 1 million. These two cities are totally dependent upon one another. It's at the mouth of the Imperial Valley. It's really about the presence of water. You can see the river moving along here and into the valley, where if you look at an infrared photo, it's all developed around the river. Population is developed around the river. Agriculture is developed around it. The labor pool moves back and forth across this border at the highest rate than any other border, contiguous border with the United States. But the interesting thing, actually, is as you think about this as being a place that is so connected and unable to disconnect, it is this post-border city. The need to create places that represent the culture of our neighbor and our own culture, a civic place that celebrates these things. You know, there's a preponderance of traffic. There's this incredible, overwhelming automobile culture, which is about people who actually never touch the ground there because they're in their cars. And then there are people who walk across the border every day, school children who come and go. You know, it's almost indistinguishable were it not for our border apparatus that, you know, this is really two different countries. So part of our study involved understanding what it was about Mexicali and downtown Calexico, how that codependence should cause us to think about the architecture differently. When there is no predominant architectural style, the streets are too wide for the buildings. You know, the cars are a dominant feature. And so we're just in conceptual design right now, but as you can see, again, moving a little too fast, but this is our site here. The river defines it. This railroad track cuts across it. There's a 30-foot drop between the city and the river. The path for the cars really those things consume the site, and yet they define the place where you can build. So finally, the buildable area becomes this arc of space, highly programmatic stuff. An arc of space which has to straddle the railroad track, needs to address the city of Calexico and its downtown functions, needs to be an appropriate civic front door from the south, and needs to make articulate the traffic component of the border. So there is this wholly other idea about being at the border and the commercial need for interface, that this is one of the only borders also that's right at a major urban intersection. Most of them would have chosen to put their border crossing, you know, 10 miles east or 10 miles west, but that codependence caused the GSA to position it here. This is a Design Excellence Commission that we won a couple years ago. And then this is a project that many Perkins and Will offices are very involved in right now. It is a university in Riyadh for 40,000 full-time graduate and undergraduate women, which just in its very idea is important. It is the largest of its kind in the world. It's about 30 million square feet of space on 2,000 acres of land just west of the Riyadh airport. And this slide, for me, just says so much. You know, this is really about women and their unveiling, the process of having places where their privacy can be had and being able to represent themselves as individuals as opposed to how they must exist when they are in the presence of men. So the veiled phenomenon is an overwhelming organizing element in terms of how one thinks about moving from an area where there are men into areas where there are not men. This is just a snapshot of a piece of the campus, but around the perimeter, because you can be seen by men, everything needs to be veiled secondary layers of screening that do not at the same time deny the opportunity for daylight and view. But once one moves through the various gateways into the central space, one can find just a very open freedom. And I have to just quickly express an experience I had which really brought this home about the unveiling. I went to a meeting where our client is the king of Saudi Arabia, but his daughter, the princess, and her academic department heads were at a meeting. And we sat, and there were two of us from two females from Perkins & Will, and otherwise a room full of men. And after the morning session, we were asked if we would like to join the women for lunch. And so we said yes, and we went in. And these women who for 3 hours had sat across from the table, and you could not really distinguish one from another, very articulate women, fully veiled, full burqa, fully veiled. The door closed, and they took off their veils, and they were just, it just transformed into this wholly familiar thing. It wasn't like it was unfamiliar. It was a wholly familiar and free thing. And for me, that just made tactile this notion of moving through life as a woman in an Islamic Muslim country, but also the idea that the veil is really something that is to be respected, but once it's no longer needed, it opens up the ability to be fully yourself. So, bling bling, high heels, blue jeans, all that stuff. This is the 2,000-acre site. This piece, number 2, is the piece that I'm working on. Miami is working on this piece. Chicago is working on this piece. It includes, Chicago's also doing a 400-bed hospital. There's a sports facility that Chicago's working on. So I think there are 5 offices. Minneapolis is also doing a piece. And this is really an intra-Perkins & Will collaborative effort where we're trying to bring pieces into a whole and an attitude into a real consistent message. So this is just a snapshot. This notion, first of all, it's going to be completed by 2011. And so the need to develop kind of a module of something that could be repeated and built very simply, that was about not only this notion of privacy, but the issue of daylight, sunlight, filtering from the sun, and being able to use the out of doors whenever possible. And these, just as typologies, part of the cultural overlay is going places, understanding the meaning of things, the use of things, the daytime, nighttime, quality of light. So just all of us, I'm sure, do this. This notion of wind towers over here, wind towers in small courtyards that allow the outdoor spaces to be used for probably 2 more months of the year than they might otherwise be able to be used. The introduction of geometries, which, as we begin to unfold, working with branded environments with Eva, the meaning of certain geometries as they relate to fertility, prosperity, and things that we can use to imbue our architecture with something more than just the components as architecture, but as meaningful elements. And some of us still do draw, so it's about looking at how to contextualize those things in ways very quickly that we can understand, using other model types, which Anthony and David are going to talk about, but really working up very quickly to an understanding of the solid against the void of the courtyard in between the 2 bars. So this is our building block again. And this particular piece of architecture that I showed you is about 3 million square feet of space as a part of the overall 30 million. And then layering it with this notion of landscape and water, and you can actually see through to the quality of the space in here, which is very private to the women. And the corridors that surround that courtyard, bringing in this notion of the screens and pattern of light and the opportunity to create contemplative space against the more traditional classroom space. And so just to conclude on this unveiling notion that as you approach this campus, after you get off the people mover, which surrounds the entire site, the women begin to find their privacy here. But if they're up in the room, they can still be seen. And so the notion of overlaying a screening device that starts to evolve, and then once you step through, it becomes very much more open and very much more of a free place is the word that's used. And then finally, Create Singapore, which is Science in the Garden, an island totally dependent until it decided in the 60s to try to become independent, and created itself rather than as a concrete jungle, rather as a city in the garden, because of some political and environmental moves that it made. And so we took on, again, winning a competition, invited competition in Singapore. We saw that the building needed to really be an organism of the place, using every drop of water, every bit of sunlight, orienting these science buildings. It's 800,000 square feet of laboratory science and research buildings, where we developed an extraordinarily narrow footprint. If that's the normal lab footprint, making it narrow and then making it as narrow as we possibly could and shifting it past each other so that the daylight can be had. And as you will see the site plan next, to begin to bring water between the buildings from the hill that's situated behind the buildings, to bring water between the buildings, to capture it on green roofs, to capture it on canopies, to move it through reclaiming systems as really one of the primary ways of designing the building. These are just looking at the sunlight studies, which allowed us to reduce the electrical loads by something like 50% from the use of daylight. But here's really the big idea, that the hill would be off to the right here, moves through the buildings, creates a garden, that garden is covered, and then the notion that the garden becomes part of the tower, which is the other piece of architecture made up of a series of slabs, also science buildings, and collecting a series of gardens, which come between these low buildings and then move up the facade on the east side. So we're shrouding that eastern-facing garden in a series of trellises and greenery. And this is a view just looking back down so that the garden really funnels through, people can move through. So this culture of the understanding of the preciousness of water and green, and things really are that green in Singapore. It's quite astounding. I think that might be the last slide, an overview here. So, David.
Process and how we as designers really engage and use technology to further design exploration. And what's really interesting about it is that it really parallels the sort of things that Eva was talking about interdisciplinary design and the way we think about how we work together. And the models of practice and the models of how we use technology are reinforcing each other. And just to sort of show you a traditional model of how we might work, there's a lot of pieces, there's a lot of parts. We have models, we have drawings, we have all of our consultants bring their pieces together, and they work in a sort of a sequential way, and they coordinate. They try to take the pieces and at various points in the process, they compare notes and look at what they have. And when we need to study something, we start another process of building another kind of model. And what's interesting about this kind of process is that it, by necessity, sort of creates a sort of a delineation line of what is design and what is production in the process. Well, the new model that we're seeing, and there's lots of names floating out there, BIM, integrated model. There's a lot of different ways of describing this, but at its core, the big idea is that there's something we sort of call the design model, and it can be a single model or a series of interrelated models, a space of investigation, and that we're all using, and is a common touchstone for a whole series of tools that all of the different experts that are part of an interdisciplinary design process actually bring to the table. So we're all looking at the same design model and using technology to let us all see what everybody else is doing. And each of us takes our expertise and our tool sets, whether it's presentation, fabrication, documentation, and uses that to affect the model, to explore different design ideas. And what comes out of it, the sort of actual documents and different things that come out of that, the studies and things, are really a byproduct of the interaction of all the different experts and all the different people on this sort of design model concept. And this is a very different paradigm, but it really meshes with the idea that as designers we're all getting in and talking about the same design problems at the same time. There's not this sort of real sequential, okay, I'm done with my part and here's your part. And so it's a different way of thinking about it that really meshes with this idea of how we actually practice. So it's very exciting in that sense. And there's some very practical benefits from that. Certainly when we're working with our consultants, we can see the structural as it relates to the architectural, as it relates to MEP, how the skin relates to that. We can go in, and even as we're looking at architecture, we can look at and find conflicts and find issues and things like that. So coordination becomes something that's part of every day of working. You're always seeing the workspace of other people and how they're thinking about a design process. Another example, and this is from the Texas Children's Project, is that models now can actually come from this design model. Physical models can actually become something that is created using 3D printing processes, CNC processes. There's a lot of tools that we use now to take this design model and see it in the physical, see it as a physical, whether it's studying a particular detail or studying a massing. A lot of these things come right from that. So there's that idea that the normal order of how we create these things can be reversed in certain cases. Another example is how we engage in the contractor. This is a design proposal that we did for the CDC. And so while the designers are looking at issues about sort of the dramatic spaces that we can create, cafeteria spaces, this sort of what we call the nexus of the interaction of the different people in the design process. At the same time, our contractor is taking the same design model that we're using in a proposal to study it, and they're looking at some very mundane questions about phasing. And they actually, as we're sort of looking at the design impact of what we're doing, they're looking at phasing issues, they're looking at staging issues, and so they actually took our model and did a very different take on it of looking at how this thing might actually be constructed, what are the staging issues. And so we're all in that same conversation. Now, this also, even within the architectural profession, has some real impact about how we actually think about how we do our work. And this is the Oklahoma project that Manuel talked about before. And design-wise, the idea is taking a sort of a typical central plan sort of idea and cutting these deep notches into it so that we get light into the core of the building. And that ends up creating these 4 pods of the building, and then each of those pods sort of lifts up or comes down to create program underneath it, and then at the top of the building we sort of were creating the spaces for wind turbines and things like that. What's interesting about this project from a process standpoint is that we committed very early in the process to saying we're going to do this in 3D, we're going to explore the design in that space, and we're all going to be looking at it in that way throughout the entire process. And that had some practical things that we were able to take our 3D even massing models and have wind analysis being done very early in the process, and then having our consultants help us really shape these sort of shrouds that we created and place the wind turbines in very specific ways, and then also strategize where the photovoltaics and things that are on the roof go. And so by having that model always there in that space, any of our consultants, any of our designers are all looking at the same thing. And and that really, I think, is valuable for architects in the profession. It means that everybody on the project, from the lab planners who are laying out these spaces, to the detailers who are looking at this, to the interiors people who are looking at how the sort of public spaces of the building actually flow through, they're all looking at the same thing. We're all inhabiting this virtual space of any building that we have. We can all walk through it. We can all see the issues. We're deep in CDs, and we can all understand exactly what the design is. The designer can still be in there, so there's no, okay, it's production time. obviously the questions are narrowing, but we're all part of the same discussions. It's a very different way of thinking about a building and engages us all in a very different way. And this is sort of the two sides of it. This is the same model, and yet on the one hand we can look at it: are we achieving the design effects that we want? What is the feel of the procession of the space? And yet at the same time we can look at issues about close coordination of the design and things like that. And so that having all these conversations happen at the same time means that we're all accountable for all these parts of the building, and so that it really gets into the sort of the core of that idea of an integrated or interdisciplinary sort of process. The second thing I wanted to talk about that's a real sort of issue is it's not just about how we're working with technology and how we're using it. The notion of what it means to build a model or modeling is really changing, and there's a lot of terms out here, and there's a lot of different ways that people break these things down. But I think what's really interesting is that we're kind of moving out of what we might call sort of an analogous process, where we all know exactly what these things relate to. I mean, when we talk about standard modeling, we're kind of in the analogy of working with clay or sculpting and pushing and pulling, and the downside of that is kind of once you get to some stopping point, you kind of throw it away and you start over, and that's kind of the standard modeling analysis. There's another kind of modeling that we sort of call component modeling, and this is kind of working from the little and building it up as sort of a kit of parts. There's as an example, this is a very literal project, design competition we did for some housing in Brazil. And we were looking at actually building these modular units as the sort of kit of parts that built up, and each of these modules would then inhabit this sort of structural framework, which would be a lot of the infrastructure of the project, and would sort of accumulate natural ventilation and a lot of the systems for the buildings. And then these modules then would start to populate a site, and everything sort of lifted up off the ground. So this is a project that went sort of from the detail and really built it up, and we started to look at what that would mean sort of from an architectural expression. Now, here's where the analogies start to fall apart a little bit, and we're into new territory. And one of the terms is sort of what we call parametric modeling, and parametric modeling is kind of coming at it from both sides at the same time. Is we've got sort of the gesture, the form, the shapes. And we've got the details and the components and the pieces. And in a parametric environment, what it means is that I can modify something over here, and all the other pieces know how to adjust and change to fit those parameters. And so, it does a couple of things. Certainly, it lets us move in a much less linear way. It means we can be looking at detailed questions, and we can be looking at big picture massing organizational questions at the same time. And if changes happen in what might not be a typical sequence, it's really not a problem. We can start to look at the two in sort of a fluid relationship to each other, which is nice. And it also lets us deal with some issues that we have actually with working with different kinds of clients and different client expectations. Leo talked about SANI. The SANI sort of charge was for us to go in and look at 4 different master plans, which Leo's group did great, a very thorough looking at these questions. But then the client came back and said, well, we'd like to see what the architectural expression meant. And that was important to them because their full understanding of these master plans really required us to speculate and start to make look at what the architecture could be. And so each of the campuses had different sort of organizational principles, but they wanted them all to be unified by a particular language or gesture. And so that the idea that we have 4 disparate campuses with 4 very different sort of massing ideas, but they wanted the sort of unified gesture of how, unified language of architecture. And that's sort of where a parametric sort of system works, is that we can take a massing and we can sort of take components that know how to populate that massing and sort of build off of it. And it lets us explore massing with a also evolving language. So in this case, we have 4 very different massing solutions, and these are based on different sort of images or ideas, whether it was silk threads or sort of mythical birds and different things that resonated with this client. And then we could take these and start to apply skins to them and and different ways of cladding them so that they all sort of take on a common language. And obviously this is a sort of a master planning look at these sort of buildings, but what we're able to do is sort of give another level of depth and understanding to a client who really wants to understand what the sort of master planning ideas or thoughts actually would mean in the sort of the buildings themselves, and also let us start to look at sort of a certain gestural language that this client was really asking for, essentially, in the language. This was one where the sort of the inspiration was of this sort of mythical bird that's of importance in Chinese mythology. But also, there's a lot of master plan ideas that were made very clear to them, by showing them these massings that they could understand, rather than something that was very abstract. And so it was very important for the way that we related to this client. And then this is another one that we did in Germany. So now the last sort of category of modeling is what we call computational or generative modeling. And this is sort of the category that's the most sort of cutting edge right now, but it's also the most sort of challenging to us. But it's very exciting. It's the idea that we actually start to use the computer to generate form. We start to bring in the design criteria and let the computer show us options that all meet that criteria. And so the key thing here is now it's not a matter of finding that form and putting it in the computer. It's a matter of framing the questions and letting the computer show us lots of options and things that work, and then we start to find the one that really seems to work the best. And so it lets us explore different design options. And this is an example on the Shanghai project of how we use this to study a very specific problem, which was they wanted to create a random variation of the sort of cellular structure that was the sort of expression of the skin, but they wanted to be able to have a control over how many units of variation they'd actually have in the surface. And so what we started to do was to look at how you could actually design a computer algorithm that would sort of create these kinds of patterns from a triangular structure, how you could start to vary it randomly, how the degree of variation could create very different looks or effects in that project, and then start to look at what the impact was on how many different unique units you might have. So whether you needed 9 units, this pattern needs 53, this pattern needs 72, and the idea is that as you change the parameters, the computer would tell you how many different components you would need based on each one. And this is something very interesting, and these are difficult problems that we're not, we haven't figured out all the ways that we can practically use them. But another approach that we used was to say, okay, well here's the we want this specific number of various units based on different lengths and combinations of sides, and by varying the actual numbers in those lengths, you create different patterns. So this is sort of the other approach. This is sort of saying, here are my units. If I vary them in different ways, this is the patterns that emerge from it. So this is a different sort of approach to the same problem. And then what's interesting, of course, is that since we're working in the computer, the next sort of realm of this investigation is taking these patterns, turning them into actual 3D objects, and then starting to put them on different surfaces and see how they actually unfold on that surface. And then because we're using 3D printers, then we can actually make little study models of these different pieces. And then obviously the next step would be thinking about things like fabrication, how you could actually build these things or make that part of the process. So at its core, when we start talking about things like generative models, performance models, and a lot of these things, we're talking about the idea of research. And we're talking about the idea of starting to push the envelope of how we approach design and the tools that we bring to bear. And in Perkins and Will, research is actually starting to become a sort of virtual community of people in a lot of different areas, whether it's EE and building technology, whether it's market sector knowledge, sustainable research, or what we're calling design lab, which is exploration of some of these design tools and tools that inform design, because they all interact and they all inform each other, and we're starting to create, and Phil talked about this a little bit, we're starting to create this sort of awareness of a sort of a research space within Perkins and Will, and a way of looking at these sort of ideas. The other thing and I want to show you one more thing, which is sort of how we start to speculate about the future and how we start to think about this. And we had the opportunity in our Atlanta office to participate in the History Channel's Future Cities competition. And what they asked us to do was to speculate 100 years in the future and think about what Atlanta might be. What we did was to sort of imagine a city where the ground plane was so valuable that it became a very preserved and highly cultivated, sustainable space, and development was limited to old infrastructure and sort of a new city that we imagined sort of above the existing city. And the notions that we sort of posited on this thing was the idea that this new city would be spaces that actually were biological and could morph and change shape based on the program that was needed at any given time. So we started to look at the existing city and then sort of pulling these things in there. So the idea is that if we're thinking 100 years in the future, it probably should look like 500 years in the future. But that's what's great about a firm like Perkins and Will is that these are the kind of things that we like to play at, because this actually really even though this isn't going to be on your doorstep anytime soon, what this is doing is starting to talk about how these sorts of tools that we're using to morph and change the way that we're looking at and exploring programmatic ideas one day could actually be spaces that morph and change. And there's a lot of back and forth there, because this is what we do when we're sitting at the computer. We push and pull and we look at different ways that spaces can align. So this is just sort of taking the leap of saying, well, what happens when that pushing and pulling is something that the building itself can start to do? So we had a lot of fun with this, as you can obviously tell. But this is just part of the way of using the same tools to start to think about the way we might conceive of architecture in the future.
We turn it to face me. So I woke up this morning and I got down to the lobby of the hotel room and I saw Bill and he had a tie on. And then I saw Manuel and he had a tie on. Leo had a tie. And so for the next 15 minutes, I'm the iconoclast. And that's only one of my problems. I'm Anthony Fieldman. I'm one of two principals that lead design out of the New York office. And I really do have a lot of problems. I think all architects have problems. And the fact is, frankly, we are problem solvers at our root. That's what we do, and that's why people come to us. It's part of the creative process. And it's things that we can do that can help them, is that a commentary? Reach farther than they can without us. So technology, I'm going to pick up on what David was talking about and talk about some of the things that we're doing right now that do at least tap into existing technologies and couldn't have really been done without current technologies. And I'm just showing you problems that some of which I don't even know how to solve yet, but certainly with people like David and with the opportunities that Perkins and Will is trying to pursue, we're trying to extend and reach our grasp farther than necessarily we have in the past. So Brunelleschi, carbon neutral, dynamically interactive buildings that Phil's going to talk about in a few minutes. These are all, well, these are problems of the day. The dome was a problem of his day. And I'm going to show you a couple of our problems. The thing about technology, though, it's wonderful, and I'm a huge proponent of it, but it can be frustrating as hell. You can sit at your computer and you can get lost in it, and people have quipped about how people can't draw anymore and they get lost in the detail, or people are drawing flashing details when in fact it's a 64th inch scale, site plan. And that's just inappropriate. But there's kind of a learning process, and technology in its best sense can free you up to look at things that you haven't necessarily looked at. So I'm going to focus this on showing you 2.5 projects, just specifically their exterior wall enclosures as elements in which technology has helped to resolve a design goal. So we're working abroad, as you've gotten the chance to see. One of the projects we have is at Kuwait University. We are doing 4 of the 27 buildings of their new master plan. Our 4 are about 1.5 million square feet between them, women's college and men's college for both arts and education. So in the College of Education, this is the women's building. It's about 750,000 square feet. Measures about 200 by 800 as a block, which is the site. It's a New York City block. It's pretty big as a building. So start with the Euclidean form, just to give you a little bit of background before jumping into the facades. We designed a whole series of courtyards that were very culturally appropriate, that were each themed to accommodate some of the larger collective programs that they shared: library, gallery, auditorium, etc. This is the library or the resource center. You can see here a site plan where the female college actually opposes the male college across what they call the oasis. And it's a very Euclidean form in one sense, filled with spaces that we're designing in a very conventional manner that are bringing daylight in or organizing spaces that we think are beautiful. And then on top of it, we've taken the non-programmed learning environments, which are productive collisions of social interaction between students and teachers, between students and people that are selling them things that they need. And we've developed a whole series of connections that then have threaded all 5 stories of the building together, bringing in certain major interventions to connect it to the other buildings on either side, and have formed a new typology, we think, for the college that starts to look at the productive collision social spaces and the more rational teaching spaces and creates a new architecture out of them that stitches them together. So this is actually the form of the building as it's developing, of this particular building, that has these multi-story adjacencies and crevices that lead you into the public spaces that are shared that I mentioned. And then this, what we call the boardwalk, that threads it all together, which has all these types of activities, exhibition spaces, study carrels, et cetera, that stitch it all together. And this was a very kind of in-depth analysis I'm not going to go into that showed where it was appropriate to bring what type of intervention in for the students. A couple of images of what that's starting to look like and how it connects you back to the outdoors and makes that type of program celebrated and legible to the surrounding buildings. And that's a summary of that type of exposure. But the skin, you know, if you haven't been to Kuwait, it's the hottest inhabited urban center in the world. And the interesting thing is, solar gain versus daylighting, structures in Kuwait City, the quantity of energy required to counteract solar gain is 12 times greater than the energy required to light spaces. So basically what you're trying to do is hold light out. It's just too bright. So there are traditional ways they've done that, although those have social overtones of actually screening women from the public, but also really kind of these solar veils and filters is what we're more interested in. So we started with an ecotech model, working with our engineers and doing some of this in-house to try to understand the energy profile of the facades in context of the fact they've got buildings on either side of them. And as you would expect, the top stories are the brightest and have the most solar gain. So we had increased solar exposure, and what we decided to do with the skin was to do nothing other than taking the inspiration of Mashrabiyah and to try to design a skin that could actually hold light out and hold the solar radiation out. So we didn't start from a conventional standpoint of trying to create something that looked like something we knew, but that achieved a certain goal. And we developed a 3-dimensional matrix to help us cowl the sun. And these things end up, you can see them in various orientations, opening up to the direction where the sun isn't and then shielding from the direction where the sun is. And they become 3-dimensional. That wasn't enough to hold all the sun out. So here again, Ecotech, we developed this glass diffuser here that threaded its way in this 3-dimensional matrix to then counteract where the sun still came in. So we developed a kind of a 2-pronged approach towards creating a facade design that got its richness from a cultural moire, but then brought it into something that had an energy goal to create the architecture by holding the sun out, but letting enough daylight in that you could daylight the space without artificial light. And it started to look like this, and you can see it from certain aspects that open up, and then other aspects that start to seem more closed. And you can see how it transforms over the height of the building into a deeper profile based on its solar exposure. So these are some very sketchy views. We're finished design development of this project, but you can start to see how in some ways you can see out and in some ways it really shields it, but becomes a pretty rich environment that we think yields a different way of looking at the exterior wall of a building because of the profile in Kuwait of that sun and its culture. So here are a couple of images starting to show the entrance and how you start to go up the outside of the building and the skin itself. In Amman, which is just a few countries over, we didn't start from the standpoint of trying to deal with an energy problem because, frankly, it's a temperate climate. It's very Mediterranean in nature, and it has seasons. Some of our colleagues that we went down there with last time in January ended up getting into a snowball fight because it was snowing in Amman and hurting his knee and having to be airlifted back because he crashed his knee slipping on the granite that wasn't really preparing him for snow in Amman. But what we did say we wanted to do was to play with something that took its inspiration from Petra. If you've ever been there, you know it's kind of hard to get away from. It's such an amazing place where space is formed by the forces of water, but rock surfaces themselves have a richness the way that they hold and reflect light. So we decided that we wanted this entire building to be comprised of major crevices that we called canyons that formed circulation paths through the hotel entrances, vertical circulation up elevators, major fissures that showed some of the program to the exterior, and then a finer grain of texture on the facades that would help make this building interdynamic with the light play as the sun moves and tracks around it in the daytime. So these are the canyons, just to give you a little context. That's the main entrance to the hotel. It's a 7-story space that's formed by a series of canyon walls. There are physical models here that were helped from us going back and forth into certain physical models, CNC routed, that we printed from a Rhino model that was able to make them so that we could test spaces. But then to quantify them, we took the Rhino model and unfolded it after we had gone to stone manufacturers and understood the dimensional limits of stone slabs, and then mapped them across these facades and then unfolded them and gave them numbers so that we could then work in certain details for a strong back with a thin veil of stone, and then with some experts that could help us mitigate these geometries by coming up with a little neoprene gasket that could take a standard cut in stone and help it bend to whatever shape it needed to be in construction without needing to make every single piece of stone customized. So that's an idea about working the computer, making physical models, and working through construction problems. That's a cut through the final canyon. In the exterior walls, here we wanted to play with the sun, as I said, not filter it out. So there was an idea. My dentist is at the top of the Chrysler Building in New York, and if you know those windows, they're very memorable. The idea was here that we wanted this hotel to become memorable to people who were in it, where a window wasn't just a window. It was something where you knew exactly where you were, and it played with the exterior of the building. So this is a typical room on the corner, and what we decided to do is take the entire facade past the canyons and crenellate it to give it some texture so that it would play with the sunlight. But to do that, we needed to systematize it, so we unfolded the whole building and came up with 2 repeating patterns of just 2 production panels other than corners that could be repeated throughout the building with the exception of certain kind of custom moments down at these canyons. And it's a very simple structure: strip windows, strip slab of concrete, although now we're going to GFRC. And it's just a strip wall system, but what it does is it has a lot of facets in it that allows it to play with light. So this is a DD drawing, but it shows very simple strip building that you find in suburbia everywhere, suburban office parks, but does it in a way that it plays with the vertical dimension and the, I guess, Z dimension in and out of the building that gets something that's repeated and modular, but ends up having a light effect that changes throughout the day, as you can see on the left. And we made a lot of physical models here at a very large scale to play with it and make something that really did dynamically interact with daylight so that it would become memorable and it would keep changing. That was important to the design team. So this is one of our models that we brought to Amman after it was finished and showed the client so they could see how their building was actually going to look. The glass itself does go in and out. It's only got 2 panels. You can see some of the glazing details. We're working with glazers to find ways to minimize the kind of complexities of that. And here with this GFRC that we're now working with, as a material that's very flexible, we're working with the same physical geometries that yielded this model to create the formwork as they cast and spray the GFRC against a mold. And you can start to see some of these kerfs. These are not just simple facets. They have a lot of kerfs that otherwise would be very difficult to build if not for what computer technology can do for you. And I don't want to take up more time, so I've just got 3 slides of the Ritz-Carlton, which is another hotel we're doing in Beirut. Interestingly, the client had a site on the edge of the Mediterranean, but no beach. But he wanted a beach hotel. So we decided we had to reinvent the typology of the hotel room to give him a beach hotel where every room was a beach. So we reinvented the hotel room in the sense that you took the one thing of a bathroom that you wanted to hide, which is the private part of it, and tucked it behind. This is the outside of the building over here. But we reinvented the room as a room and a spa. And the spa, which was a cabana with its screen, had a demising wall out of glass that could be slid open and closed. So you could shower open air with the windows open, but you could have the veil of the screen that would give you the privacy that you needed, which obviously has all the solar protection that comes with a screened element and a very deep balcony with big day beds, so you felt like you were in a cabana, and a tub that you could sit in and look out over the Mediterranean. And then we took it and we replicated it a whole lot of times into a building form. It's supposed to move. Oh, there it goes. And slotted it into a system that got its inspiration from Rowlett, which is Pigeon Rocks in Beirut. If you've ever been there, it's one of the national monuments there. It's this striated rock formation that all of Beirut has been built on through 7 layers of civilization, and an amazing limestone set of striations and layers. So we populated the building with a condominium tower and a hotel tower with a pool halfway up the bottom, bars and restaurants up at the top, and conference center at the bottom. And this is what it looks like. We're working on the screen right now to develop it with Bill Zahner as a kind of a perforated stamped metal that's perforated first and then stamped into its form. He's one of the only guys that's really pushing design in that sense, as I'm sure you've seen on the De Young Museum in San Francisco. He's doing some pretty great stuff. And we hope he's going to help us build these cabanas in the sky. And with that, I'll let Phil take it home like Holmes did last night.
I won't introduce myself, I think. And I am not the guru on green in the firm, but I'm going to try my best just to sort of finish up on this because, as I said earlier, it's a core principle of our practice. And I'm going to talk specifically about the issue of the big question mark. If you're talking about we've got problems around carbon neutrality and global warming and how buildings use energy in a broad sense. This is part of an overall strategic plan we have around sustainability, and one of the components is a commitment to meet something called the 2030 Challenge, which was developed by a group called Architecture 2030. You've probably heard about it, which sets these energy reduction targets. The problem that we have in the world, in this country, is that buildings use 50% of the energy. Transportation, cars, we talk about fuel use a lot because it's more of a political issue, but they only use 20%, and then industrial use is 30%, something round numbers like that. So the architects and designers and mechanical engineers have a real opportunity to make a big difference. And essentially this red line is the projected growth of energy use, and the green line is what the 2030 Challenge calls us to use, which is to reduce energy in buildings at these rates. This is something that, and these are strategies. Let me move on ahead. Some of the detail, just by the way, the Commercial Building Energy Consumption Survey, something called CBEX, is the standard against which we are trying to target reductions. This is a survey of a couple thousand buildings around the country in different building types, and this is the energy used in those buildings, and it goes down over time because there's projections that buildings will use less and less energy. Today, this is what LEED uses, the LEED standard, which is ASHRAE 90.1, so it beats the current standard, but only by about 30%. And then if you get to LEED design buildings, you get down to this level. The Architecture 2030 goals are trying to reduce relative to the existing building platform. So this is obviously a very audacious goal, and the question we have is, one more thing, is that the federal government has adopted these goals for federal buildings. Okay, so there's now laws in place that will require us to meet these goals in federal buildings, which is interesting. And let me just back up. And there are 550 mayors in North America who have committed to meeting the goals. Now, all of these people, we think, have made these commitments without knowing how they're going to accomplish them, which is a really problem. It becomes our problem, right? So we want to do it because we think it's good stewardship. And cities and our federal government had committed to doing it, but for the moment, our industry doesn't know how to do it. And so one of the things we're doing, and I'm going to give you a couple examples here, is doing research specifically into accomplishing this. The first thing we're doing is developing a set of metrics for measurement of buildings, because for the moment, we're talking about every building. We're not just talking about the 1 or 2 or 10 buildings in each office of Perkins-Will where we do energy modeling, but we're talking about every single project that we're doing in the whole industry. So we've created a tool which is just about to be released, which is an energy forecasting tool which has the various components, and it's complicated business, and we're not engineers, but we're running it through mechanical engineers to actually seriously be able to predict the energy use in all buildings in our firm. So this is a research effort that's underway, and this spring will be released. Just some context, just by the way, in order to reach those objectives, if you measure them in terms of tons of carbon emitted and settlement patterns, we've got a pretty audacious problem. And actually, Houston, I know we're not in Houston now, but we're near Houston. It is actually one of the largest energy users of cities in the world. The U.S. average is 24 tons of CO2 per person, and the projections are we need to get down to 2.2 tons per person with 8 billion people on the planet in order to get down to the levels where global warming supposedly will stop. This is very, very speculative, but the problem is quite massive, as you can see. We've got to reduce energy uses by 10-fold. So just a couple of projects that are in the works that try to address this. And some of these are relatively conventional projects. This is an office building which uses many sort of high-tech strategies that are fairly common in Europe today. In this particular case, it's a double-wall construction. So in European buildings, especially in Germany and UK, those kinds of temperate environments, a double wall works well as you basically create an extra layer and use that as a cavity to evacuate hot air or cold air, depending upon the season. That strategy by itself doesn't get you far enough. And in this case, we looked for synergies, and the building happens to be situated next to a hockey arena, and so we were able to come up with a strategy to disconnect the existing hockey arena from the grid, use the excess heat from the building to heat the hockey arena, use the excess cooling from the ice making to actually cool the building. So this is a strategy which uses synergies with buildings that happen to be next to each other, sort of serendipitously, to accomplish that. So this is something this is a building that is in design. Moving on, this is the Center for Interactive Research on Sustainability. This is a more innovative building that uses just about every technique we can think of to get to energy efficiency or energy, going off grid. This building uses all its own water and recycles it. It uses, it tries to use all of its own energy, but doesn't quite get there. And let me flip through these quickly. So this is the ASHRAE standard. This is how much energy we can get if we use everything we know how to use, and we're still not down to zero. And then we're using some photovoltaic power, and so we get down to 9%, but we still have to buy green certificates. So we still can't figure out how to design an ultra-green building. This building, we also went back and used heat off of an adjacent laboratory building, heat recovery, to help in the process. The other thing that's interesting about this building is it uses all wood framing as a building material, and with the theory that wood itself is a sequestration, it sequesters carbon, and so we're actually finding a place for carbon that is in the atmosphere in the building so the construction process itself is carbon negative, but the building then still uses carbon. A major area of focus is in communities now, and the opportunities today exist more. It's easier to reach these kinds of carbon neutral goals if you look at systems, campuses, or large-scale developments. And so this is a project in Victoria, British Columbia, which uses an entire community and synergies that exist between multiple buildings, residential, office, retail, and so on, and campus energy development systems to reach a neutral environment. So there's biomass energy cogeneration, so they're using all the waste, and they're incinerating to create energy. They're treating all their own water, and this is what it looks like. This is actually the sewage treatment facility right on site. It becomes an amenity. And this building, the buildings are relatively conventional. They're only 42% below, but because we're developing our own energy, about half that much is generated on site through the renewable heat generation. But then we still need to use green power certificates. So that's all to say that this is a really hard problem, and we're trying hard to look for ways to solve it, but we still haven't come up with a way to come up with carbon neutral buildings. I just want to finish on this project. I just kind of like it, so I want to show it to you. This is a botanical garden building in British Columbia, and it emphasizes the whole necessity to look at whole systems in the entire site. And I'm really not going to get into detail because I want to leave time for questions. But all the water systems are considered on site, not just around the building, but we're looking at the entire opportunity for how we can recover water and retain water and recycle water. This is the building itself. The building is also made out of wood, entirely out of wood. All these shapes are laminated structures, and it captures all of its own water. So there's no water used by the building. There's no energy used by the building, but it's really a pavilion. So we're not talking about a very large energy user, and there's recycling of composting and these kinds of things. So the multiple strategies, and use this the last slide, just making the point that these objectives are comprehensive in nature, and you have to look at every strategy and every environment to result, and you still have work to do. So this is kind of a big glaring question mark for our world is what are we going to do about it and how we're going to get there, but I think the more people work on it, the more rapid advances we'll see. So I want to finish up on that and leave some time for Q&A, and thank you very much. Let me turn this off. Where's the reception? We got one question here. Okay.
I'm deducing that some of the software that you use is Revit, because you mentioned about mass and components, and you already mentioned Ecotech for daylighting analysis. What other softwares are you use in the energy analysis of your projects, and also what are the problems that you face regarding to interoperability between different softwares or disciplines?
Yeah, and what's interesting is that this is really a work in progress, and when you talk to the software companies that are developing these tools and looking at these issues, they don't really have the answers yet about how all these things work together. There's a lot of ways to do it, and when we think about tools right now, there's no one tool that will solve all your problems, and there's not any completely clean interface about how they all work together. As a firm, we're using Revit as a standard platform for our modeling, and that's starting to have possibilities for its mechanical platform actually doing certain kinds of analysis within it. The Ecotech is more of an architect's tool, but is really, for the architect, a standard tool that we're using to analyze things, and the moving of things in and out of Ecotech is a challenge. 3D Studio now is developing design tools that let us analyze daylighting and other solar issues. We're also looking, and this is sort of just in the conceptual phase, but what we're interested in doing is starting to look at generative tools like generative components and similar tools that actually let you start to take performance data and information and bring them in. And what's interesting right now is that our engineers have tools that they use to analyze building performance. We have tools that we use, and the real sort of challenge within the industry is exactly what you're saying, which is interoperability, how tools work together, how to move from one tool to another and actually maintain data. And I think that what's good is that all the tools are getting much more open to that movement. Tools like Rhino that Anthony was talking about are becoming very flexible and common platforms that people are using. And what's interesting is you're getting a lot of third parties that are going in and creating plugins for Rhino or plugins for for Revit and tools that let you do the analysis inside these programs. And so when we talk about a methodology and a building model, it's not one model, it's not one tool, it's a family of tools. So, that diagram is tools that we bring to a common set of data, essentially, that lets us all look at problems in different ways. And there's a lot of different sort of answers and ways of working that we're seeing in different projects.
Just to add one thing, I think one of the interesting things is that a lot of the tools that we had previously entrusted to our consultants to help bring to the table are things that we are starting to use ourselves in-house, whether it's Ecotect or whether it's the DOE2 software where you study the whole energy profile, or whether it's Radiance that studies light and how actually light bounces in the space is completely different from energy modeling. And we see a lot more people coming out of schools either knowing these things or being interested in these things. We fully encourage that because it helps us reach farther than we would be able to without them. And what it lets us do is fold those tools into a design investigation where we're asking questions the way only a designer would ask questions that an engineer might not. We can partner with them, but the more we understand them, the more we can push our own boundaries and use it as a generative part of our design process instead of just one that's reactive.
Going back to the Women's Education Center in the Middle East, I recall you had mentioned that there were multiple offices like the Miami and Chicago office, as well as other offices working. From experience in the Dallas office, working with the HCA projects, just working with the California office alone was a challenge in itself. How did Perkins and Will manage to coordinate that large-scale project with multiple offices?
We thought you were doing that.
Yeah. I think this project is extraordinarily large, but I think it first of all begins with a good sort of connection in the Middle East. So we have a number of people over there working with us. We have partners in the Middle East. We have another design principal working in the Middle East who is really the overarching designer for the project. And then each of the offices has its own leader. But then each of the leaders actually has a big team. I think our team is probably 40 people in San Francisco. I think the digital tools become extremely important. I think that always having, and I'm going to use the wrong words here, David, I'm sure, but having a Revit model, each of us having our own Revit model that can be put together, that can be transformed with outside consulting sources to take that Revit model and create consistent imagery, realistic imagery, some of which I showed. We're just into maybe middle of design development on this project right now, and so we're still at the point where we're trying to just make sure that our square footages are properly taken off. So there's a lot of interface from office to office that's very much about computer-based kind of accounting for square footages of our screens and things like that. I would say once every 2 weeks we all get in the same room though, whether it's in Chicago or Miami or San Francisco or Beirut or Cairo, and that's the place where the individuals who can carry as much of the critical knowledge, the critical conceptual leadership get together, and we account for where we are, so that although the project isn't meant to have a homogeneous quality about it, because it's being all done by Perkins and Will, there is an essential kind of connection that we have to have periodically that's more than just the computer.
You showed the Hayworth Center and you showed the Tribune Interactive as renovation projects. And much of this discussion and many things I read about sustainability and sustainable architecture have to do with getting to start over and not necessarily recognizing the embodied energy that already exists in so much of our infrastructure and so many millions and billions of cubic feet of enclosed space. Could you talk about the opportunities that you see for your firm in terms of looking at more renovations or rebuilding, reskinning, however you want to think about what we already have?
Yeah, I'll address that. We've got a couple answers to that. One is yes, by 2030, we think about 50% of the existing building stock needs to be renovated or significantly reconfigured, and so that's a major program. The federal building program that is part of the current stimulus package is exactly these energy efficiency retrofits, but it's not just a matter of going in with new light bulbs and putting in fluorescent bulbs, but it's reskinning buildings to make them high-performance buildings, and we've done some of that, and I think there's an opportunity for a lot more of that. You know, it's obviously a very green thing to do, to use an existing structure if you can, as opposed to having to start over. The other piece of it is historic preservation, and it's an area that we're beginning to get more involved with, actually adaptive reuse and trying to preserve the cultural artifact of buildings where they really are a high-quality building, and then carry them forward in some other purpose. And I know that's an issue here on campus, and it's something that we're also beginning to get more involved in. But you're absolutely right that there's a big opportunity to make high-performance buildings out of existing buildings. Loose fit, long life is a general good principle of design. And I have to admit that I worry that some of our very specific, programmatic, focused design solutions sometimes seem to be not particularly loose fit. You want to design just shoe boxes, and they could become an office building, they could become a hotel, they could become whatever in the future. And these are very, very specific solutions. On the other hand, I think you can design buildings to be demountable, or you can take them apart again, or you can recompose them. So, not a real answer, but I think a very good question.
Well, all you have to do is look at some of our cities to see what happens over decades and decades when a building is no longer what it was, and things evolve, and you'll see everything that used to be an office in New York is now an apartment building. And so even if they're designed very specifically, there will always be people who are clever enough to adapt them into a new use. And just want to add with one analogy that doesn't necessarily answer the question, but I read recently that the Prius as the kind of gold standard of hybrid design, unless you can afford a Tesla, is something that you would have to drive for 10 years in order for you to capture enough energy savings of just not buying a new car. So, no matter how energy efficient we are with our new stuff, frankly, if we reused our old stuff and adapted it, it would immediately be better in terms of a kind of a sustainable profile than raising it down and putting up a new one.
And another issue with the sort of highly programmatic buildings that we do is that a lot of them are actually, and this is something we recognize, they're a lot of the worst sort of energy hogs programmatically that there are. One example is like this Oklahoma project that we were looking at. We use wind turbines. We had PVs actually on. We actually got them to put PVs over their entire campus, the amount of energy that we saved in this process is the equivalent of 50% of the energy usage of an average office building. But that only equates to a 10% savings in the energy usage of a typical lab building. And these are the kinds of clients, the kinds of programs that we're trying to work within the sustainability model. And these are also the kinds of things, also healthcare, that there's more and more of demand for. So we realize that this is not only a difficult problem, but a critical problem, because this is where a lot of the growth in architecture and also the growth in energy use is coming.
Please.
You talked about on one of your designs starting early on with 3D modeling, but the way you said it's kind of suggests that you don't normally start out too early on in that. At what point in the process do you start bringing in computer modeling, and why is it at that point that you bring it on, and why not earlier or later in the process?
Who said that?
Let me start off by answering that, because Eva talked about the overall trend of speed being a driver, and I will say that clients' demand for speed and feedback and decision making is extremely high. And so as designers, I think I've heard the term rapid design prototyping being used, and I think that we pretty well throw every tool we have at a problem to come up with some way to explain or analyze or talk about a problem. And early on, you don't want to get burdened by a huge amount of data to manage early in the process, i.e. a big Revit model that's fully coordinated, but you want to use 3D tools, you want to use hand sketching, you want to use physical models, a bunch of arrays, and test ideas out very rapidly, because I think speed is very, very important. And then I think you get into a process of getting a little bit what David's talking about. I mean, you might do some Revit early on, but I don't know if you can comment to that.
In fact, I wanted to jump in. You know, I'm going to get in trouble here, but Revit is a tool that can be flexible, but is not necessarily the most flexible tool for what I term the equivalent of the hand sketch gesture, right? Where you can just get stuff out on trace really quickly. You can test things. They're imprecise. You don't worry about the precision, and you just get ideas out. I think Rhino is a tool that certainly has that flexibility inherent in it, something that we use sometimes day one. SketchUp is another tool that's in our stable of things we use that are also very loose and fast, and they don't try to pretend that you're going to solve everything day one, but that you're going to still allow that loose investigation that a tool that's quick and responsive can let you do. Some of the tools have a better ability to then slide into and communicate with other tools that are more specific without throwing that information away. But we certainly use three-dimensional tools from the very beginning. I mean, it's just the reality of what's available and what allows us to extend our reach.
Yeah, and I would add that, you know, it's important for us not to get too wrapped up in which tool we're using. And there's a lot of, I think, not particularly useful debate about this tool is better than that tool. Really, the bigger issue is how we're using tools and how we're using them to inform design. And that when we're doing concept design, that we use our tools conceptually, and we use them to solve the problems and the questions that we need to solve at concept design. Now, what's interesting is the questions and the problems are getting different, more challenging, more interesting, actually. And so the kinds of tools we might bring in early in the process may be very different than what we would use, and the kinds of questions that we can look at early in the process because of the kinds of people we're bringing to the table earlier in the process. So the whole idea is strategic use of tools to solve the design problem. And for every project and for every designer and for every process, that's different. But designing the process is as critical as designing the project. And a lot of times, you know, we shoot ourselves in the foot by getting too wrapped up in what we perceive as the right process rather than looking at each project anew and really looking at tools often that we've never used before. Say, this problem really calls for something completely different, you know, or a different way of using a tool. And I think that those kinds of questions about process that we always ask from the specific design process that we're familiar with, we start to also ask about the tools, because you shouldn't bring the same tools to every project. You shouldn't, and you shouldn't use tools in the same way at every point in the process. And I think that understanding the trade-offs of how tools are used and where in the process different tools work well, how they work, is really a critical question. And it's one that is, what's interesting and exciting is it's rapidly evolving. I mean, it's every time we think we know what the process of the workflow is, it changes because somebody introduces a new plugin for this, or a new way to use this, or a new release of software changes the equation dramatically. And one example of that is that, last year we were looking at generative components, because that was the generative tool out there? Well, this year there are several generative tools and highly parametric tools that have been released for Rhino, for example. Autodesk has hired the developers of generative components away from Bentley, and they're now developing a generative tool. So the dynamic is there, and the industry realizes that they need to provide new tools to solve new problems. And it's very exciting, and we're all in the middle of it. But it means that at every given moment, we need to reevaluate and resort out the problem. And that's very exciting, and it's a lot of fun because it means that we're constantly looking at new ways of approaching the problems. But definitely, it's more than knowing a certain tool. It's that willingness to approach every design problem and to approach technology in a limber and sort of flexible way.
We'll take one last question and then leave the
Do you think LEED accreditation completely addresses the problem of sustainable design today? And
No.
and the sustainable future?
Absolutely not.
No,
It's an imperfect.
Go. What's the second part of your question?
And why?
And why? We have actually put a lot of energy and emphasis on LEED and have gotten behind the USGBC aggressively because we think it's a great place to start. We think it's sort of a point of entry into sustainability, and it's actually a relatively low hurdle to jump over to get moving. It's also been a great tool in our firm to build consensus. I mentioned nearly 1,000 LEED accredited professionals in our firm, which works out to being like 65, almost 70% of all the design professionals in the firm. We're getting there, and that's created a basic dialogue. That being said, it's just the beginning, and it does not address everything, and so we're already looking beyond LEED in many ways in terms of much more aggressive targets around energy performance. LEED at the moment does not address this 2030 challenge. It will in coming versions. We think the issue of water is not adequately addressed in LEED especially, and other areas as well. So, but it's a great place to start, and we think that having just an opportunity to have something of commonality as opposed to people arguing between LEED and BREEAM and other standards that are out there, that's not productive. We just want to get going with something. And I think that's generally the professional opinion, that LEED has become a standard, which is useful to have a standard. So.
And just to add something as a teaser, LEED and other living building challenge, things like that, have challenged us to use less, but the new holy grail is actually not using less, but actually creating buildings that regenerate landscapes and contexts and places in which they inhabit that are very much tailored to a particular place, which is a real challenge because you can't apply wide strategies to something that specific in the way that ecosystems are so fragile and so specific. So and we've convened some panels internally to help us try to understand how we can not just use less, but give back more. And that's, I think, where we are headed as a firm, is in trying to see if we can insinuate architecture to the point where it no longer has the effects that architecture have had to date on its surroundings. Maybe learning from from people several thousand years ago that did this really, really well.
Okay. All that stands between the program and the reception, so I'll be very short. First, thank you. Thank you at multiple levels for the excellence of the presentation, the thoughtful dialogue that's already going inside my head, and above all, for validating a lot of the choices that we have made as a college and through our departments, because we didn't have a chance to chat. This is not scripted. This is true from the heart, from you to us. And like I said this morning, when the best meet the best and end up better. You've touched on a lot of things that have become prime directives for the college. Globalization, cultural sensitivity, looking at the future without forgetting the past, an understanding and a respect for technology on what it can do and an awareness of what it cannot do and how it's people that make the bridge between all of that. It's about interdisciplinary collaboration. It's about really everything that I think we are trying to put in place, and that in many cases we already have in place. So this is just a very simple thank you from my perspective, and on behalf of all the department heads, center directors, faculty, students, and staff, former students, and friends of the college. I'm going to let Valley say the last words, but I just wanted to have a chance to say thank you. Gracias.
Thank you.
Gracias.
Gracias.